Continuing in 10.1, and we're looking at Amplifier Basics. Characteristics of amplifiers are common across devices, including integrated circuits. Gain is a term to indicate the increase in signal given by an amplifier. Gain is expressed as gain equals output over input and is commonly represented as A. Amplifiers may be designated to amplify current, voltage, or power. Gain or loss can also be expressed as decibels, as in dB. Decibels are based upon logarithms and provide a convenient way to express very large ratios. Conversion formulas for voltage, current, and power are. And so here we have the conversion to decibels for voltage, current, and power. Now you'll notice here for voltage we're going to take 20 log of the output over the input. And let's just do some examples here. Let's pretend that our output voltage, and we'll just use very round numbers for ease, the output voltage is 100. The input voltage is 1. So if we were evaluating gain, we'd say the amplification was the input is, or the output is 100 times larger than the input. Now, to look at the gain in decibels, we will need to bring out our calculator, and so we're going to say 100. And then we'll take the log of 100, which is 2, and then we need to multiply it by 20. So times 20 equals, and the value is 40. So we could say that we have, and what we commonly do say, is that we see 40 decibels of gain in this amplifier, and this would be voltage gain, 40 dB of voltage. Now, keep in mind that when we use the term decibel, this is a unitless value, and by that I mean this simply represents the relationship between input and output. Since we had 1 volt of input, 100 volts of output, we're taking the log, or 20 times the log of 100. Let's look at current, and we'll amplify this thought. Let's say we had the same amplifier, and this wouldn't necessarily be always the case, but let's just pretend that in the same amp we also had a current gain, and this time the current gain would be 100 milliamps, and we had 1 milliamp of current. Like I say, this would not necessarily be the case, but just for ease of numbers, again, we'll do the same thing. Now, we could say the current gain is 100, just simply say 100 times the input. Now, if we were taking the log of that, if we took 20 log times, and again it would be just 100, we'd get the same thing. Again, we would say we get 40 dB. Now, the fact is here that this is a much smaller unit. This is in milliamps, but the ratio remains the same, so the output is the same. Again, we're looking at the decibels is unitless. It simply represents the relationship between input and output. And when we're looking at voltage and current, the relationship is going to be 20 times the log of that value. Now, when we look at power gain, we're going to find that power gain is not 20 log, it's going to be 10 times the log. Now, recall that when we calculate power, it is a function of voltage and current. Now, amplifiers are usually optimized for either voltage, current, or power, but when it comes down to the final analysis and you have to calculate what is the power, you simply look at what is the voltage and what is the current in the circuit, and you multiply them out. So what we could do, if we pretended that this was the same amplifier, we could pretend that this is the same we want to evaluate the power for this amp, and we say, well, we had 100 volts of input, we had 100 milliamps of output, so that would represent the 100 times 100 milliamps would represent the total power. So 100 times 100 is 10,000, but to keep our units right, remember this is watts, and since this is milliamps times 100, then this would be milliwatts. And our input, we would have 1 volt times 1, and again this is in milliamps, so this would be 1 milliwatt. So now we're looking at 10,000 milliwatts of power. Now that's quite a difference between 100 over 1 and 10,000, but we're looking at the same amp. So let's again look at our calculator and calculate what is the power out here. And so we start out with 10,000, and we take the log of that. Now notice this time it's times 10, so times 10, and notice that we still get 40. And so interestingly enough, remember this is actually what we would expect since this is the same amplifier, and this kind of brings into play why do we take 10 times the log by 20 with voltage and current. Okay, let's take a little closer look. With our voltage gain, we had 100 over 1. Remember that when we do decibels, we're looking at the log. And remember, when we do logs, we're thinking about the log represents the exponent. And so when we take the log of 100, we're looking at what exponent would we raise 10 to get this value. And so in this case, the log would be 2. And so the log of 100 is 2. And so, and remember that 10 times 10, that's where we get that value. And then since we're doing the decibels, remember to calculate the decibels, we would take 20 times that exponent and times 20, and that's where we got the value of 40 dB. With power, it was much the same. We had the value was 10,000 over 1, and so again the log represents the exponent. If we had 10 and we wanted to find out what is the exponent that we would raise 10 to get 10,000, well, that value would be 4. And so if we just took the log of 10,000, we would get 4, but to convert it to decibels, we would take that times 10, and hence we get our value, which we previously calculated, which was 40 dB. Okay, this addresses the first item that we were looking at in this section, which has to do with amplifier basics. And so we were looking at the term of gain. So we looked at the value A, which represents the value of amplification, and then we looked at converting that gain into decibels, which are generally used to represent very large values.